Hello dear friends, welcome to the first lecture of Strength of Material. Now those of you who are visiting our channel for the first time, let me just briefly explain it to you about our YouTube channel. It's called Unacademy GATE ME, where we post live video lectures of all technical and non-technical subjects by the top faculties, the top educators of India, completely free of cost. So if you are preparing for any competitive exams in the field of mechanical engineering, GATE, ESE, SSC, IPET, whatever exams you are preparing for, you will get all the video lectures related to those exams completely free of cost on our YouTube channel. So if you have not subscribed our channel till now, please subscribe the channel and press the bell icon so that you can get the notifications of all our video lectures which will be live. Yes, you heard me right, the video lectures will be live. So please press the bell icon, please subscribe our channel, and if you like our video lectures, you can hit the like button and you can share it with your friends so that we can get to the maximum number of students. Okay, so the complete video lectures will be free of cost. We will post the video lectures of all technical and non-technical subjects. So just by watching our videos on YouTube, you can prepare for these exams, competitive exams, GATE, ESE, SSC, IPET, whatever competitive exams you are preparing for. But if you want a more personalized learning from the top educators of India, you can buy the subscription of Unacademy Plus. Unacademy Plus is a platform, online learning platform, where you will get video lectures of the top educators of India. So if you want a more personalized learning, you can buy a subscription of Unacademy Plus at a very minimum cost. The cost is one-fifth of the cost of classroom coaching that you go to right now. So you just buy the subscription of Unacademy Plus and you will get more personalized learning. Now, what are the advantages of Unacademy Plus? What are the advantages of buying subscription of Unacademy Plus from our team, by using the coupon code of our team members? Let me just explain it to you. So if you use my coupon code APPROVE10, what all things you will get? You will get 10% instant discount on your subscription. You will get 10% instant discount on your subscription. The other advantages, you will get all the video lectures in a very structured manner. So 2 or 3 subjects will be completed parallelly. Once those subjects will be covered, then the next video lectures will be uploaded. So your subjects will be covered in a very structured manner, in a very organized manner. All the video lectures will be bilingual, means they will be in Hindi as well as in English. So there will be no barrier of language for anyone. Okay. Now, apart from the video lectures, what benefits you will get? So let me just explain it to you about the benefits of buying Unacademy Plus subscription using the code of our team members. We have a team of top educators of India. Let me just tell you something about myself. My name is Aprup Rao. I have a 6+ years of teaching. I have taught more than 100 batches for GATE and ESE. Students preparing for GATE and ESE. I have been teaching for more than 6 years now. I have an MTech from IIT Kharagpur in the specialization of mechanical systems design. So all the educators in our team have a very huge experience. They are the best educators of India. So if you buy subscription using the coupon code of our team members like this, APPROVE10, this is my coupon code, you will get 10% instant discount. You will get all the video lectures bilingual in Hindi as well as in English. And what more you will get apart from the video lectures? You will get daily practice problems. You will get daily practice problem, level 1, level 2, level 3 questions related to all the video lectures, related to all the topics. Okay, so you don't have to worry about from where I have to pick the problems, which standard textbooks I have to refer. So you will get daily practice problem, and the solutions of these problems, will be discussed live by the team of top educators of India, our team of top educators of India. So the solutions of these DPP will be discussed live in a very close group. Only you will be a part of that close group. If you buy the subscription using our coupon code, then only you will be put in that close group. You will get the DPPs and you will get the solutions live discussed by the top educators of India. What more will you get? You will get mock tests. You will get mock tests related to the video lectures, and the solutions again will be discussed live by the team of top educators of India. Okay, and the third thing, which is the biggest of all, now please hear me, the third thing which is the biggest of all is you will be a part of a closed Telegram group. It will be a closed Telegram group. What do I mean by a closed Telegram group? Only you will be part of that closed Telegram group if you buy the subscription of using our code, using the code of our team members. You will be a part of a closed Telegram group where you can post all your questions, all your doubts. You can post numericals. If you are stuck in any problem, you can post that problems, and the solutions of those problems will be done by our team, the top educators of India, on daily basis. Okay, so you'll be part of this closed Telegram group where you can post all your queries, all your doubts will be personally monitored by us. This group will be personally monitored by our group. We are also part of this closed Telegram group, but you will be part of this closed Telegram group only if you buy subscription of Unacademy Plus using the code of our team members. Like my code is APPROOP10, APUROOP, APPROOP10. You get 10% instant discount. You get DPP with live solutions. You get mock tests with live solution, and the biggest of all, you will be a part of closed Telegram group where you can post all your doubts, all your queries on daily basis. It will be monitored by us. You will be mentored by us. We will have one-on-one discussion. You will be mentored by us. So you will be part of a closed Telegram group. Okay. So don't forget to use my coupon code APPROOP10 when you are buying the subscription of Unacademy Plus. The cost is very minimal if you compare it with other institutes, classroom coachings. The cost is very minimal, and you get all these benefits. You get all these benefits which you will not get in a classroom coaching. Okay, all your lectures will be completely organized, completely structured, so you don't have to worry about those. Okay, so your experience will be just like classroom coaching, even better, because you don't get these things in a classroom coaching, but you will get all these benefits if you buy Unacademy Plus subscription. Okay, now let me just tell you the difference between YouTube videos and Unacademy Plus. You will get live lectures on YouTube Plus also, but here your lectures will be organized, structured, and you will get all these benefits. Okay, so buy Unacademy Plus subscription at a very minimum cost using my coupon code APPROOP10. Okay, now one thing that I have to tell you, we have started this initiative #GATE Prep Daily. So don't forget to follow this hashtag on Instagram, and what benefits you will get? You will get all the posts, all the notifications related to your preparation on daily basis. So please follow #GATE Prep Daily, and you will get all the benefits. You will get all the posts, all the notifications regarding your GATE preparations on daily basis on your Instagram. So go to your Instagram and follow this right now, #GATE Prep Daily. Ask your friends also to follow this. We are starting this initiative just now. We have started it just now, #GATE Prep Daily. Okay, so follow this on Instagram and you will get all the notification, job notification, all the relevant posts on your Instagram feed. Okay, and if you have still not subscribed to our channel, please go and subscribe our channel. Press the like button, share it with your friends, and press the bell icon also, so that you get notifications of all the videos, all the live lectures we are posting on YouTube. Okay, so we have just started posting video lectures of GATE. Okay, there are very fine educators, top educators of India. There is a course of industrial engineering right now going on by Mr. Amit Dikshit sir, top educator of India. There is a course of fluid mechanics started by Mr. Devendra Singh Negi, top educator of India, AIR1. All these people are AIR1, Amit Dikshit sir, Devendra Negi sir. So please subscribe this channel and you will get video lectures of all these top educators on your YouTube. Okay, now without any delay, let's start with our lecture of strength of material. Okay, now before I start with the video lecture, let me just tell you that the setup that you are seeing right now, the setup that you are watching right now, is a temporary setup. Because of the lockdown, I couldn't go to my studio, so that's why you see here whatever you are looking at. the video quality, the audio quality, they might not be proper, because whatever I had in my house, I have to start the video lecture with that. I don't want to waste your time. I want you to utilize this time, this period of lockdown. So that's why I have started the video lecture with whatever setup we have. Okay, so please don't judge us based on the temporary setup that we have. Once the lockdown is over, we will start the video lectures in a studio. There will be a smart board, there will be a high quality video, there will be high quality audio. So if there is a problem with video and audio, please bear with us, because this is all we can manage in the lockdown period. We don't want to waste your time. We want you to utilize the time of lockdown period. That's why we are starting the videos by whatever equipments we have at our home. Okay, so please subscribe this channel, hit the like button, share it with your friends, so that we will reach to maximum number of students. Okay, so let's start with the video lecture of strength of material. Now before we get into understanding whatever we have in strength of material, let's first understand what the subject is. What is strength of material? So strength of material, my friends, strength of material is a part of mechanics. So let's first understand the meaning of the word mechanics. Okay, if you see a structure or a machinery, if you see a tall building or if you see a lathe machine, that structure or a machine consists of several members connected together, and all these members are applying forces on each other. All these members are connected to each other, so they are applying forces. Whenever you start a machine, whenever you use a structure, what is happening? All the members connected to each other, they are applying forces on each other. So what is mechanics? Mechanics is the study of forces and its effects on the bodies. We study about the forces and we study about what happens to the body due to that force. Okay, for example, let's pick one member of your building, let's pick one member of your house, let's pick a beam. So this is the beam. Okay, you can see this beam in your house. So this is a beam which is connected to several members, and all those members and this beam are applying forces on each other. Okay, so let's say that this beam is resting on two columns. So those two columns are applying forces. Let's say this beam is subjected to the weight of the structure. So that is also a kind of a force. So this beam is subjected to all these forces. Now what we have to do in this subject, we have to study about these forces. What is this force? What is this force? What are these forces? And we have to study what will happen to this beam due to these forces. Now why are we worried about the effect of these forces? Because if you want to design this beam, then you have to know what will happen to this beam due to all these forces. Whether these forces will break this beam or not, whether these forces will move this beam or not. If you don't know the effect, then how will you design this beam? For example, let's say these forces are trying to move this beam. So you have to stop the beam from moving. These forces are trying to break this beam. So you have to stop this beam from breaking. So you'll only be able to do that if you know the effect of these forces. So what is mechanics? Mechanics is the study of forces and the effect of these forces on the body. Now, there are two different categories of mechanics. Mechanics of rigid body and mechanics of deformable body. Now what do we mean by rigid and deformable? When you apply external load on any material, if that material does not deform, then it will be known as a rigid material. And if the particles of that material deform, then it will be known as a deformable material. Okay? Now practically there is no such thing as a rigid material. All the materials are deformable. Whenever you will apply external force, there will be some deformation in the material. But in some cases we assume that the material is rigid. This is just an assumption, this is just an idealization. In some cases we assume that the material is rigid. Okay, let me just take an example. Let's say you have a cantilever beam. which is subjected to 100 Newton force. Length of this beam is 2 meter. This is point A, this is point B. Now, what will happen to this beam under this force? This beam will bend. Okay, if you apply a 100 Newton force, this beam will bend like this, and this angle of the force, the length of this beam, it will completely change. Now, if I ask you what is the moment at point B, if I ask you what is the moment at point B, then you will not be able to calculate the exact moment if you are considering this bending. If you are considering this deformation, then you will not be able to calculate the moment at point B. So what we do, if this deformation is negligible, then we will neglect this deformation. So now it is very easy to calculate the moment at point B. 100 into 2, 200 Newton meter. So what I have done, we are neglecting the deformation of the material to calculate the moment at point B, means we are assuming that this beam is rigid. So in some cases, if you want to calculate the effect of the force, then you have to assume that the material is rigid so that your calculations will be easy. If this deformation does not affect the effect you are studying, okay, the effect means, let's say I am calculating moment at point B. If this moment is not affected that much by the deformation of the beam, then I don't have to consider the deformation of the beam in order to calculate the moment. I can just neglect that deformation. My calculations will become very easy. So that's why I have assumed that the material of the beam is a rigid material. Okay. So whatever we study in engineering mechanics, you have a subject called engineering mechanics. Whatever we study in engineering mechanics, that is mechanics of rigid bodies. Okay, in engineering mechanics, what do we study? We study the external effect of the forces. Okay, what will happen outside the material due to the force, whether the body will move or not. If it moves, what will be the velocity, what will be the acceleration? These are external effect of the forces. So if you are studying external effect, if you are studying motion of the body, then you assume that the material is rigid. Why we are assuming it? So that our calculations will become very easy. If you consider the deformation in engineering mechanics, then it will become very complicated. Your calculations will become very complicated. So that's why we are neglecting it. Okay. Now deformable bodies means these bodies, this material will deform under the external force. Now deformable bodies are of two types, solid and fluid. What is the difference between solid and fluid? In solid, the deformation is finite. Means if you apply force, there will be some finite deformation, 1 mm, 2 mm, 10 mm, whatever the deformation is, it will be finite. You can calculate it. But in case of fluid, the deformation is infinite. Infinite means a continuous deformation. The fluid will start to flow. Okay, so it will not be able, the deformation will not be finite. You will not be able to calculate it. It will be continuous, a continuous flow. So deformable bodies are again of two types, solid and fluid. Now, whatever we study in strength of material, that is the mechanics of solid bodies, and whatever we study in fluid mechanics, that is the mechanics of fluid or fluid mechanics. Okay, so there are three types, three branches of mechanics: mechanics of rigid bodies, mechanics of solids, and mechanics of fluids. Mechanics of rigid body is termed as engineering mechanics. Mechanics of solid is termed as strength of material, and mechanics of fluid is known as fluid mechanics. So these are three different subjects in mechanical engineering, but all these three are branch of mechanics, which is nothing but study of forces and its effect on the bodies. Okay, we study what is the force acting on the body, and we study what will happen to the body due to this applied force. Okay, now in strength of material, what we have to do, there are two things that we need to calculate: stress and strain. There are two things that we need to calculate: stress and strain in different bodies under different external loads. So there are different type of external loads. There is axial load, there is bending, there is twisting. So due to all these external loads, what will happen to the material, what will happen to the body, that we have to understand. So in strength of material, all the syllabus can be divided based on the type of external load. There will be a chapter for axially loaded members, there will be a chapter for bending, there will be a chapter for twisting. So what we will do, we will calculate stress and strain under different loading condition, under different type of external load, and we will divide all these chapter based on the type of load. Okay. Now, before we start calculating the stress and strain, we have to first understand the basic concept of stress and strain. What is stress? What is strain? That we have to first understand. Then only you will be able to calculate these things. Okay. So this first lecture is all about the introduction of stress and strain. Okay. The first 1 or 2 lectures will be only about the introduction of stress and strain, where we first understand the basic concept of stress and strain. If you don't know what is stress, what is strain in great detail, if you don't have your concepts cleared about stress and strain, then you will not be able to calculate it. Okay, so first we need to clear our concept, basic concept of what is stress, what are types of stresses, why I am doing this, why I am calculating this, why I am calculating it on this particular plane. That we need to understand first. Then only we will be able to calculate it. Okay, so this first few lectures will be only about understanding the basic concept of stress and strain, which are very important if you want to understand strength of material from basic. Okay, now if you have still not liked and subscribed our channel, please go and subscribe this channel first, like this video first, and then start this video lecture. Now let's start with the introduction of stress. Let's start understanding the concept of stress. In order to understand the concept of stress, I'll take a very simple example. What examples I will take? Let's consider a cylindrical body. Okay, let's consider this body is cylindrical and it is subjected to an axial force. Okay, this force is an axial force. What is axial force? Axial force is nothing but a force applied at the centroid of the cross section of the body. Okay, and it acts longitudinally, in the longitudinal direction. So this is an axial force. Okay, now first what we need to do, we need to draw the free body diagram of the body. Whenever you are calculating stress, first we need to draw the free body diagram, because we need to know whatever external forces are acting on the body. Okay, so if you draw the free body diagram of this bar, this is called a bar, what you will get? This is the force P. Now at this point the body is supported. Okay, and due to this support there will be a reaction. Okay, and if you apply equilibrium equation, summation of Fx equals to 0, net force in x must be 0. Why? Because this body is not moving. Okay, so if the body is not moving, means net force in x direction must be 0. This is known as equilibrium equation. Okay, so if you apply this equilibrium equation, the reaction here will also be equal to P. So these two forces, this P and this P, what are these forces? External forces. So first, whenever you get a problem in strength of material, what do? We draw the free body diagram and we find all the external forces. Without these external forces, we will not be able to calculate stress. Okay, so we have found out the external forces acting on the body, this P and this P. Now what we need to do? We need to calculate stress, and stress is an internal phenomenon. Stress is developed inside the body. Okay, so what we need to do, let's say we want to calculate stress on this plane. Okay, let's say we want to calculate stress on this plane. So what we will do, we have to find out how much force is developed on this plane. Okay, the forces developed inside the body are known as internal forces. The forces acting outside the body are known as external force. So this P and this P, these forces are external forces, and the forces developed inside the body are internal forces. Now first let's understand what are internal forces, how they are developed. Because if I tell you that stress is internal force per unit area, you will be confused how these internal forces are developed. So let's first understand how the internal forces are developed. Okay, when you apply a force on the body, what happens? Let's say there are 2 points, point A, point B. Okay, right now they are connected together by means of bond. The particles of this solid body are connected together by means of bonds. Okay, these bonds are nothing but like springs. So when you apply a force, what will happen? These particles will deform, these particles will move from their position, their initial position. So this bond will act just like spring. If you apply force on spring, what will happen? Let's say I am applying a tensile force on spring. So the spring will elongate, but the tendency of the spring will be to come back to its original position. So in the same way, what will happen? If we apply a force P, point A and point B will try to move apart from each other, but due to this bond, their tendency will be to come back to their original position. So there will be a force like this, there will be a force like this acting between point A and point B. This force acting between the particles is known as internal force. So why this internal force is developed? My friends, whenever you apply external force on a solid body, the particles of the body will deform, but they want to come back to their original position. They are resisting the deformation. Their tendency is to resist the deformation. Like spring, if you apply a force on spring, spring will elongate. But what will be the tendency of the spring? To resist this deformation. So the spring wants to come back. How do we know this? How do we know it is trying to come back? Because when you remove that force, the spring will come back. So that proves that it has a tendency to come back. Otherwise, if you remove the force, what will happen? The spring will stay there, but the spring does not stay there. If you remove the force, the spring will come back to its original position. Means it has a tendency to come back. It has a tendency to resist its deformation. So just like that, here also, all the particles inside the body, there are infinite particles inside the body. So all these particles are subjected to this force. They are resisting the deformation. So there is internal force inside the body. And what do we want? We want to find the internal force on this plane. Okay, we want to find the stress, and in order to find stress, first we need to find the internal force on this plane. So what we will do, listen to my friend very carefully, because this is the basic concept of stress. In the entire strength of material, whenever I will say find the stress on this plane, you have to do the same thing. So what we will do, if you want to find the stress on this plane, you will cut the body from this plane, because we want to find internal forces, what is happening inside the body. So until and unless we expose the body, until and unless we expose the inside of the body, we can't find the internal force. So I will cut this body from this plane, and I will draw the free body diagram of either the left part or the right part. I can draw the free body diagram of any one part. Okay, free body diagram of a body can be drawn by considering the entire body or by considering parts of the body. It doesn't matter. If a body is in equilibrium, parts of the body will also be in equilibrium. So right now this body is in equilibrium, net force is 0. So if I cut the body and draw the diagram of any one part, that part will also be in equilibrium. This is the basic concept of engineering mechanics. You will study all this basic concept in engineering mechanics, but in strength of material also you need this concept. So time to time I will tell you what are the basic concepts related to this. Okay, so if a body is in equilibrium, if you cut the body into two parts, these parts will also be in equilibrium. Why we are cutting the body? Because we want to find the internal force. We know the external force, this P and this P, these are external forces. We need internal force. So what we will do, I will draw the free body diagram of both the parts. Although you don't need the free body diagram of both these parts. Even if you draw a free body diagram of left part or right part, you can calculate the stress here. But in order to understand, I will draw free body diagram of both the parts. So this is the left part, okay, and this is the right part, okay. Now I told you that if the body is in equilibrium, part of the body must also be in equilibrium. Summation of fx must be 0. But can you see the summation of Fx to be 0? No. Because here there is a force P acting on the left side, nothing on right side. Here there is a force P acting on right side, nothing on left side. So what will happen? On this plane, this is the plane from which we have cut the body. Let's call it YY plane. Okay. So this is YY plane. On this plane, there will be internal forces because these particles, the particles on this plane, they are trying to come back to its original position, like here. See, this particle A, this particle B, these are forces. Why these forces are developed? To resist the deformation. So these particles which are now exposed, I have cut the body, so these particles are now exposed, they will experience a force like this. Now understand the difference between these forces and this force. This is external force and these forces are internal forces. Okay, why these forces are developed? To resist the deformation of the body. Okay, so what I have done, I have cut the body into two parts and I have drawn the free body diagram. Just to understand, I have drawn both the parts, left and right, but if you want to calculate stress, you only need free body diagram of any one part, either the left part or the right part. Okay, so let's see this left part. Okay, now what is the definition of stress? If you want, you can note it down. Stress is defined as internal forces per unit area on a given plane. So if you want to calculate stress on this plane, what you need? Internal forces per unit area. Now from here, I will tell you a few points which you need to note down so that you will be able to understand the concept, the exact concept of stress. What is stress, why it is developed, how it is calculated, why it is calculated in this particular manner. If you want to understand all this, note these few points, my friends. Okay, so first thing, the definition of stress. Stress is defined as internal force per unit area. Okay, now if you want to find out internal force per unit area on this plane, what do you need? First you need to know the total force on this plane. Okay, means the sum of these forces. These are internal forces on every point. Now we need the sum of these forces. The sum of these forces can be calculated just by equilibrium equation. Summation of Fx equals to 0. So if you apply equilibrium equation, the sum of these forces will be equal to P and the sum of these forces will also be equal to T. Okay, so we have calculated the sum of these forces. So the sum of internal forces, the net internal force, can be calculated by equilibrium equation. But stress is not the total internal force. Stress is internal force per unit area. Now I need how much internal force is acting on the plane per unit area. Now that, my friend, is not very easy to calculate. Why? Because we don't have any equation. In order to calculate the net internal force, we have equilibrium equation. But if you want to calculate the force per unit area, you don't have any equation. Okay, you can't use equilibrium equation to calculate stress. You can use equilibrium equation to calculate net internal force. But internal force per unit area, that you cannot calculate. So stress cannot be calculated just by equilibrium equation. In order to calculate stress, we need how the forces on this plane are distributed. For example, if the forces are distributed equally, this is known as uniform distribution. Okay, here the forces, internal forces, are uniformly distributed. Here the internal forces are linearly distributed. Here the internal forces are parabolically distributed. So in all these cases, you can see that the internal force per unit area will be different, because here internal forces are distributed uniformly. They are equal at every point. Let's call this point A, point B, point C. So the internal force at A, internal force at B, internal force at C, they are equal. But here internal force at A is different, internal force at B is different, internal force at C is different. Here also at A, B, C, internal forces are different. This is uniform distribution, this is linear distribution, this is parabolic distribution. So here we only know the total internal force P, but we don't know whether this P is uniformly distributed, linearly distributed, parabolically distributed. Okay, and until and unless we know this thing, we can't calculate stress, because stress is internal force per unit area. So how do we calculate stress? So now, my friend, the real concept begins. So the first thing, why internal forces are developed? Internal forces are developed to resist the deformation. Okay, so let's say there are two springs. One is deformed by 1 mm and one is deformed by 5 mm. So which one will experience more internal force? The spring which is deformed by 5 mm. This is trying to resist 5 mm deformation, and this is only trying to resist 1 mm deformation. So in this case, in 1 mm deformation, internal force will be less, and in 5 mm deformation, internal force will be more. So internal forces depend upon the deformation. If the deformation is less, internal force will be less. If deformation is more, internal force will be more. You can say internal force is directly proportional to deformation. Okay, so now in order to find internal force per unit area, total internal force we have calculated from equilibrium equation, but we need internal force per unit area, and we know internal force is directly proportional to deformation. So my friends, note this point: internal force is directly proportional to deformation. If deformation is less, internal force will be less. If deformation is more, internal force will be more. So if you know how the body is deformed, you can find out how the internal forces are distributed. Linearly, parabolically, how internal forces are distributed, that we can calculate if you know the deformation, how the body is going to deform. Let me just give you an example. Here we are considering axial force. This is an axial force, means the force is acting at the centroid of the body. This is the centroid of the cross section. And if you apply an axial force on centroid of cross section, what will happen? The body will deform, but it will remain straight. It will not bend. Okay, if the forces are not acting at centroid, what will happen? The body will bend, but right now the body will not bend. Now look at the deformation, my friends, from top to bottom. Let's consider this plane. Okay, from top to bottom you can see deformation at every point is equal. If the body remains straight from top to bottom of the body, let's say this is a body. Okay, I apply an axial force on the body elongates by 5 mm. From top to bottom of this cross section, at every point deformation will be equal. It will be 5 mm. If the body bends like this, then from top to bottom deformation is not equal. At every point deformation is different. But if it remains straight, that means deformation at every point is equal. And if deformation is equal, my friend, internal force is directly proportional to deformation, then the internal force at every point will also be equal. If deformation is equal at every point, then internal force will also be equal at every point. Okay, so in this particular example, if I want to calculate stress, how will I calculate? I know total internal force is P. I know total internal force is P, and now I know that internal force at every point is equal. So now what will be the equation of my stress? It will be internal force P, total internal force P divided by total area. Let's say this area is A. So now the equation of my stress has become P by A. Why? Because now I know that the internal force P is uniformly distributed. From top to bottom, internal force is equal. Okay, how I know this? Because I know how the body is going to deform. So if you know how the body is going to deform, you can find out what will be the distribution of internal force, whether it will be distributed equally, whether it will be distributed linearly, whether it will be distributed parabolically. So under different loading condition, deformation is different. Like here, the bar is straight. If you apply bending moment, the bar will bend. So under different loading condition, the deformation is different, and if deformation is different, my friend, then the distribution of force will also be different, the equation of stress will also be different. So this equation I have written here, P by A, it is only valid if the internal force P is equally distributed, uniformly distributed from top to bottom, and this happens in case of axial force. So this is the equation P by A which you can use for axial force. So just to understand the concept of stress, I have considered this example of axial force because it is very easy example. So that's why I have only considered axial force. But the equation of stress under different loading condition will be different. Suppose the internal forces are distributed linearly, then what equation you will get? Here you can see P by A, this is a constant equation, but here the stress will vary from top to bottom. So here you will get the distribution of a line, you will get an equation of a line. If the internal forces are distributed parabolically, then the equation of stress will be a parabolic equation. So in different loading condition, the deformation is different, and depending on that deformation, the distribution of internal force will be different and the equation of stress will also be different. So in order to calculate stress, what do we know? What do we need? We need equilibrium equation, because by equilibrium equation we can find the net internal force. But just by knowing net internal force we can't calculate stress. What else do we need? We need how the internal forces are distributed, and this is done by the deformation of the body, because internal forces are directly proportional to deformation. Okay, so if you know how the body is deformed, you can know how the internal forces are distributed. So we need net internal force, which is calculated by equilibrium equation, and we need internal force per unit area, internal force distribution, which is calculated by deformation. So these two things help us to calculate different types of stress: equilibrium equations and deformation of body, how the body is deformed. In some cases we know how the body is exactly deformed, and in some cases we need to assume how the body is deformed. We can't find the exact deformation, so what we do, we assume how the body is going to deform. That we will see in later chapters, in which cases we assume the deformation of the body, what assumptions do we make. Okay, now if you have not subscribed this channel till now, this is not fair, guys. This is not fair. You can see the content of my lecture. It is top class quality. It is top notch content. So please subscribe this channel. You will get notifications of all our video lectures. Press the bell icon. You will get the notification of all our video lectures. Okay? And like this video, then only I'll be able to know whether you are liking my teaching or not. Like this video, share this video with your friends. I want to get to maximum number of students, so that maximum number of students who all are preparing for different competitive exams get benefited from our YouTube channel. Okay, there are top educators in our team: Amit Dikshit sir, Devendra Negi sir. There are SSC JE team. There are people who are launching SSC JE videos are also. So please subscribe this channel and you will get video lectures of all our faculty. There are 8 members in our team. Each one of us are top educators of India with lots of experience of teaching students preparing for GATE, engineering services, SSC JE. We are launching 2 programs right now for GATE and ESE and for SSC JE. So there are different lectures for GATE, there are different lectures for SSC. So you can get benefited from all these video lectures if you subscribe this channel, and if you press the bell icon, you will get the notification of all our lectures. Whenever we will be live, whenever we will be posting the videos, you will get the notification. So press the bell icon also, my friends. Okay, and if you want to understand Unacademy Plus subscription, what are the benefits of Unacademy Plus, you can contact me directly on my number also, my friends. I will clear all your doubts about Unacademy Plus. 7000534184. This is my personal contact number. You can contact me. My name is Aprup Rao, and I will guide you throughout the process. I will tell you about what are the benefits of Unacademy Plus, what are the benefits of subscribing to our team. Okay, my team consists of particular educators. Okay, there are 8 educators, top class educators. If you buy a subscription for from our team, then only you will get benefits. What are the benefits? I told you in the beginning of the lecture. If you have not seen it, you can see after the lecture ends. You will get daily practice problems, live solutions of those problems. You will get mock tests, live solution, and the biggest of all, you will be part of a close Telegram group where you will post all your queries, you will post all your doubts, you will post all your questions, and they will be answered on daily basis by our team. Okay, top educators of India we have in our team, and it will be closely monitored. That group will be closely monitored, but you will be part of that closed group only if you buy Unacademy Plus subscription from our team. Okay, so my code is approved 10. My code is approved 10. I am again telling you, my code is approved 10. Please use this code when you are buying the subscription. Okay, better you call me, give me a call, I will guide you through it so that you don't make any mistake. Okay, because whenever people get nervous about the money, they make mistakes, you will not get 10% discount and you will not get all these benefits if you don't use this coupon code. Okay, all right. So my friends, we have understood the concept of stress, why the stress is developed, how the stress is developed. Okay, but I told you that in different cases the equation of stress will be different. Okay, so in different cases you will get different equation of stress. Here we are getting P by A. Okay, now let's understand the unit of stress. Whenever you calculate stress, you have to find the stress in a particular unit. Okay, so what unit do we use? SI unit of force is Newton. SI unit of area is meter square. So the SI unit of stress is Newton per meter square, which is known as Pascal. My friend, SI unit of stress is Newton per meter square, which is known as Pascal. But we don't use the SI unit of stress. Whenever we calculate stress, we calculate the stress in Newton per mm square. The area is calculated in mm square. Okay, so the stress is in the range of 100 Newton per mm square, 200 Newton per mm square. Now Newton per mm square means what? If you convert mm square into meter square, how much you get? 1 mm means 10 to the power minus 3 meter. 1 mm square means 10 to the power minus 6 meter square. 10 to the power minus 6 will go up, it will become 10 to the power 6 Newton per meter square. And what is 10 to the power 6? It is mega, and Newton per meter square is Pascal. So this is known as megapascal. So whenever we calculate stress, we calculate it in Newton per mm square or megapascal. So throughout strength of material, whenever we will calculate stress, we will use this unit. Okay, so if your area is in meter square, you have to convert it into mm square. Okay, and then your stress will be in megapascal. This is the unit that we will follow. Okay, all right. So now we have studied what is stress. Now we have to see different types of stresses. I told you, under different loading condition, there are different types of deformation. Based on that deformation, distribution of internal force will be different, and if distribution of internal force will be different, then the stress will also be different. Equation of stress will also be different. Okay, so what do we mean by different types of stress? Let's understand that. So we will see types of stress. So basically my friends, stress can be divided into two parts: direct stress and indirect stress. Okay, now first we need to understand the meaning of these words, direct and indirect. What do I mean by direct stress? What do I mean by indirect stress? Okay, so the example that we considered earlier, this example P, in this example I told you that I am applying a force P like this, and I am calculating the stress on this plane. Okay, you can see that this force is directly acting at the centroid of this plane. So this is known as a direct force. So whatever stress you will get here, it will be a direct stress. But consider this case. Let's say I am applying a force P here and I am calculating the stress on this plane. So now you can see that the force is not acting at the centroid of this plane. So this is known as an indirect force. This is a direct force. It is directly acting on the centroid of the plane. This is an indirect force because the force is acting somewhere else and the centroid is somewhere else. Okay. So in this case, what do? In this case, you will transfer this force P on the centroid of the plane. My friends, note this down. Whenever a force is acting somewhere else on the body and you want to calculate stress on a plane, what you will do, all the forces has to be transferred on the centroid of the plane. So let's transfer this force P here, okay? So let's say this distance is E. So if you transfer this force P from here to here, what you will get? You will get a force P and you will get a moment, okay? So you will get a moment P into E. So now this plane is subjected to a moment also. Here you will not get any moment, okay? Because why? Because force is acting directly at the centroid. But here the force was eccentric, okay? This is known as eccentricity. So the force was eccentric, so now we are getting a moment. So this is known as a case of direct stress and this is known as a case of indirect stress. So my friends, in easy words, if you want to differentiate direct stress and indirect stress, in easy words, in simple words, you can say direct stresses are developed due to forces and indirect stresses, my friends, are developed due to moments. Okay, so whenever there is a moment, whatever stress you will get due to that moment will be known as indirect stress. Okay, so there are direct stresses and then there are indirect stresses. Now direct stresses are of two types. Why, my friends? Because the force can be acting like this. The force can also be acting like this. What is the difference in these two cases? In this case, if you consider this plane, the force is perpendicular to this plane. And in this case, if you consider this plane, the force is parallel to this plane. So in this particular case, whatever stress we will get, the force is acting perpendicular to the plane. So in this case, whatever stress we will get, it is known as normal stress, which is denoted by sigma. And in this case, if you are considering this plane, the force is parallel to the plane. So whatever stress we will get, it is known as shear stress, which is denoted by tau. Now my friends, you will say, in this case it is normal, in this case it is parallel. But what will happen if a force is neither parallel nor normal? If a force is acting like this, let's say this is the plane and the force is acting like this at some angle theta. So what you will do? You will resolve this force. So you will resolve this force. This will become P sin theta and this will become P cos theta. So now you have a normal force and a parallel force. So in this case, you will get both the stresses, sigma as well as tau. So a force can be acting normal, you will only get sigma. A force can be acting parallel, you will only get tau. And if the force is inclined, you will get both sigma as well as tau. So these are the two types of stresses because of forces. Okay, direct stress, normal stress and shear stress. Now let's talk about moment. So my friends, in case of moments, okay, whenever you apply a moment, there are two types of moment. Okay, for example, let's consider this body. Let's say this is a cylindrical body. Okay, let's consider three axes. Let's say this is x-axis, this is y-axis, this is z-axis. Okay, this is the cross section. I want to calculate stress on this cross section. And now I am applying moment. Here I was applying force. In this case I will apply moment. Indirect stresses are developed due to moment. Now moment can be applied about x-axis. Moment can be applied about y-axis. Moment can be applied about z-axis. This is mx, this is my, this is mz. Okay. Now the nature of these moments are different. Why? Let's understand it using an example. Let's say this is a body, cylindrical body. Okay. So what is your x-axis? This is your x-axis. This is your y-axis and this is your z-axis. Okay. Apply a moment about x-axis, my friend. Okay, this is your x-axis. Apply a moment about x. this moment will try to turn the body, twist the body. So this moment that I am applying about x-axis is known as a twisting moment. But apply a moment about y-axis, my friend. Y-axis is this one. Okay, this is the cross section. Y-axis is this one. So if you apply a moment about y-axis, what will happen? This will try to bend the body. Similarly, if you apply a moment about z-axis, this is z-axis. If you apply a moment like this will also try to bend the body. So you can see there are two types of nature of deformation: twisting, bending. So one moment is known as twisting moment and one moment is known as bending moment. Okay. Now, if I ask you to imagine every time, in every question, if I ask you to imagine whether it is bending or twisting, it will not be possible. Okay. So how will you differentiate a bending moment and a twisting moment? Very easy, my friends. Look at this axis, x-axis. This is a twisting moment. X-axis is normal axis of this cross section. But look at y-axis and z-axis. These two are bending moment, right? This is a bending moment, this is a bending moment. My and mz. So y and z axis are what? Parallel axis of cross section. So if you apply a moment about normal axis, it will be a twisting moment. Normal axis moment, twisting moment. Parallel axis moment, bending moment. So just remember these points because we will use this concept in the later chapters. Okay, so you need to understand difference between bending moment and twisting moment. If you are getting a moment, I will ask you whether it is bending or twisting. So at that time what you will do? You will find out about which axis the moment is acting. If it is acting about normal axis, my friend, it will be twisting moment. If it is acting about parallel axis of the area, it will be bending moment. So if you are calculating stress on this plane, there are three axes. One is normal and two are parallel. So moment about normal axis is twisting, moment about parallel axis is bending. Okay. So now you know that if there is a moment, it can be bending or it can be twisting. So there are two stresses, my friends. There are two stresses. In case of bending, the stress is known as bending stress. And in case of twisting, the stress is known as torsional stress. Now bending stress is also a type of normal stress because in case of bending, whatever internal force is developed, that is also normal. Here also internal force is normal. Here also internal force will be normal. So this is also a type of normal stress, sigma. But what is the difference between these two? In this case, distribution of stress will be different and in this case, distribution of stress will be different. So my friend, nature of stress is same. Here also stress is perpendicular to area. Here also stress is perpendicular to area. But both stresses are different. Why? Because the equation of stress will be different. The distribution of stress will be, distribution of internal force will be different. Okay, so both are normal stress. And here also, in case of twisting, in case of torsion, the stress will be shear stress tau. So this is a direct shear stress and this is a torsional shear stress. Both are shear stresses because in both cases, the internal force will be parallel to area. Okay, this is the area, so internal force will be parallel. In this case also, in this case also. But what will be the difference? In this case, the distribution of stress will be different. In this case, distribution of stress will be different. So the equations of stresses will be different. Okay. So now you know that the stresses are all four types: direct normal stress, direct shear stress, bending stress, torsional stress. Now we are not considering how the stresses are calculated. We are only understanding what are the different types of stresses, my friend. So calculation will start from the later chapters. Right now we are only understanding a basic concept. So I am only telling you the basic concept of all these types of stresses. Okay. So now you understand how many stresses we will deal with in strength of material. Okay. My friends, the lecture is about to end. So one more time, let me tell you that if you subscribe this channel, you will get all our video lectures completely free of cost. Okay, so please subscribe our channel. You will get completely free of cost video lectures. Okay, bilingual lectures will be there. We will post lectures in Hindi also and English also. So don't worry about the language barrier. Okay, my friends. So please subscribe this channel. If you subscribe this channel and you press the bell icon, you will get notifications of all the video lectures that we are going to post. Okay, there are video lectures of industrial engineering going on, there are video lectures of fluid mechanics by David Negi sir going on. So please subscribe this channel, okay, and you will get the video lectures of all these amazing faculties. There is a batch of SSC JE also, my friends, so if you are preparing for SSC JE, you will get benefited from those video lectures also. So please subscribe this channel. Please follow this hashtag, my friends, GATE Prep Daily. Please follow this hashtag GATE Prep Daily. This is something that we have recently started. If you follow this hashtag on Instagram, you will get posts, you will get notifications related to everything that we will post on Instagram related to GATE prep. Okay, so your GATE preparation, all the post, job notifications, everything related to GATE preparation on daily basis will be there on your Instagram feed if you follow this GATE Prep Daily. And if you want more personalized learning from the top educators of India, you can buy a subscription of Unacademy Plus using my coupon code. This is my coupon code, approved 10. If you use this coupon code, I told you about the benefits, 10% instant discount, and you will be part of our team. Okay, there is a 8-member team, 8-member faculty team. You will be closely monitored by us, mentored by us. It doesn't mean that you can't see the video lectures of other teams. You can see the video lectures of other team also. Okay, you can see video lectures of everyone. Okay, whoever is teaching for GATE and ESE, you will get the video lectures of those people. But if you subscribe to our team, if you use the coupon code of our team, you will get certain advantages which you will not get from other mentors. What advantages you will get? Daily practice problem, live solutions, you will get mock tests with live solution, and the biggest of all, close Telegram group where you can post all your doubts on daily basis, my friends, which will be closely monitored by us. We will put all our efforts in that group so that all your queries, all your questions are answered on daily basis, my friends. Okay, so if you subscribe Unacademy Plus using my coupon code, you will get all these advantages, my friend. If you have any doubts related to Unacademy Plus subscription, please contact me personally, 7000534184, and I will guide you throughout the process so that you don't make any mistake, my friend. Okay, so this was the first lecture of strength of material. Please comment and tell me if you like this video or not, what else you like in this video, what are your queries. If you have any doubt related to this particular lecture, you can also put it in comment. I will try to answer each and every one of you. And if you like my video, if you like this lecture, please hit the like button and share with your friends so that I can reach to maximum number of students. This is a period, a lockdown period, my friends. All of us need to take the maximum advantage of this period. Okay, so that's why we have started with the minimum equipments that we have. I had this board in my house, so I had to start the video lecture using this board, my friend. But once the lockdown is over, I will start the video lecture in my studio where I have a smart board, where the proper lighting is there, proper audio will be there, so everything will be fine. But my friends, although the equipments are not up to the mark, but the content of the video lectures will be up to the mark. Okay, so please ignore all this and just focus on the content of these video lectures. You will never regret it. You will never regret learning from us. Okay, so this was the first video lecture on strength of material. I will post the entire syllabus on YouTube channel, my friends. So please subscribe the channel. I will post the entire syllabus of strength of material free of cost. Okay, so nothing will be skipped. Don't think that I'll post only 3-4 lecture and then I will stop. No, I will post the entire strength of material, my friend. So just subscribe this channel and you will get all the video lectures, related to GATE and ESE, related to SSC JE on your YouTube channel. Okay, so my friend, this was all. This was the first video lecture, my friend. Thank you for watching. Thank you for listening.